the mini lesson for 4.2. Use the number line and determine the number described by each. So we want the number that is 7 more than negative 9. So I need to realize, first of all, that I'm starting at the negative 9. So if I'm here and I want 7 more, I'm moving this way 7. 1, 2, 3, 4, 5, 6, 7. And I would end at negative 2. The number that is 2 more than negative 6. Again, I have to ask myself, where am I starting? I must be starting at negative 6 to then go 2 more than that. 2 more, be moving to the right, I end up at negative 4. The number that is 10 more than negative 8. If I'm at negative 8 and I go 10 more, just getting to 0 would be 8, 9, 10. I would end at 2. Now they're talking less than, so they want the number 10 less than 6. If I'm at 6 and I go 10 smaller, I'm going this direction. So it's 6 to get here, 7, 8, 9, 10. I end at negative 4. The number that is 5 less than negative 4, if I'm starting at negative 4 and I'm going even less, I'm moving this direction 5 places, 1, 2, 3, 4, 5. I end at negative 9. And the number that's 2 less than negative 4, I start at negative 4 and go 2 less, I end at negative 6. So a number line is a very useful model when we're talking about adding integers. When adding a positive integer, we move to the right on a number line. When we're adding a negative integer, we move to the left. So for example, the number line shows how to determine 5 plus 8. So you did this back when you were in elementary school, learning how to add. We started at 0, we went over to 5. From 5, we added 8 more to end at 13. Here they're showing us 5 plus negative 8. So I'm starting again at 0, we moved to 5. Now we're adding 8 negatives. We're moving in a negative direction 8 places. So 5 to get me back to 0, 6, 7, 8 to end at negative 3. So what distance is shown by the first term in each example? The first term is 5 in each example, so it's 5 units. Describe the graphical representation of the first term. Where does it start and in which direction does it move? So we always start at 0 and we moved 5 units to the right because our number is a positive 5. Because 5 is positive. So now they ask me, what is the absolute value of the first term? Remember, absolute value is written like this. It's the 2 bars on either side. And you learned about absolute value, I believe, last year. Absolute value of a number is its distance from 0. So 5 is 5 spaces from 0 on a number line. So now we're going to compare the second step in each example. The second step, we either added 8 or added negative 8. So what distance is shown by that second one? It still was 8 units. In one of them, we moved 8 units to the right. The other, we moved 8 units to the left. What did the graphical representation for the second term? Why did it both start at the end point of the first term, but then continue in opposite directions? When we moved to the right, we were adding 8 positives. We moved to the left when we added 8 negatives. So what are the absolute values of the second term? Well, in the first one, the absolute value, we added 8. In the second one, the absolute value, we added a negative 8. But the absolute value is the distance from 0 on a number line. So 8 is 8 units from 0 on a number line. Negative 8 is also 8 units from 0 on a number line. The negative just tells me the direction, but it's 8 units. So if I look here, 0 to negative 8, it is 8 spaces away from 0. That's what that refers to. So we are going to use the number line to determine each sum. Remember, when I see the word sum, I know I have an addition problem. So first it tells me to go to negative 3. So I start at 0, and I go to negative 3 on the number line. Now this is going to be my new starting point. I'm adding 7 positives. Positives mean I'm moving to the right 7 spaces. So 3, 4, 5, 6, 7, and I end right here at positive 4. This one looks very similar, but I'm starting now at positive 3. So at 0, I go to positive 3. From there, I'm adding 7 negatives, which means I'm moving in a negative direction 7 spaces, which means I'm ending right here at negative 4. Now we have negative 3 plus negative 7. So I'm starting at 0 always, and I'm going to negative 3. From negative 3, I'm adding 7 more negatives, which means I'm moving left 7 more spaces, and I end at negative 10. And this should be the easiest one. I'm starting at 0, going to 3. From 3, I'm adding 7 positives, so I'm moving to the right 7, and I end at positive 10. So in all 4 of these, notice that the first term in each expression was either a 3 or a negative 3. What do you notice about the distance shown by these terms on the number line? In all of those cases, we moved 3 units. What's the absolute value of each term? So it was either a 3 or it was a negative 3. Both of those are just 3 units away from 0 on a number line, just opposite directions. Notice that the second term in each expression was either we were adding 7 or we were adding negative 7. So what do we notice about the distance shown by these terms on a number line? We moved 7 units again. Sometimes left, sometimes right. What's the absolute value of each? The absolute value of 7 is 7. The absolute value of negative 7 is also 7. Okay, this is where we will start our work time and end our mini lesson.